everybody. Today I'm with Trevor Beugeling, who's the instructor in our engineering design class. And Trevor, you want to tell me about what your students are up to?
Yeah, so these are students in our Applied Science 123 class, which is our engineering design course. So the engineering program as a whole is a first-year engineering program that allows students to essentially get their first year of their undergrad engineering program done, and then they transfer on to a university to finish off the remaining 3 years. So this course specifically focuses on teaching the students about the engineering design process. It's a multi-step iterative process for essentially identifying a problem, brainstorming solutions, coming up with the constraints for the problem and so on, building prototypes, testing those prototypes, and then going back and improving on the design until it's ready to go to market or something like that. So the context that they're learning this design process in is robotics, using the VEX robotics kits. So essentially they have a project where I've asked each group to come up with either an objective for a robot or a problem that they would like a robot to solve, and then work through the design process to build a robot that solves that problem or performs that task. And then they have to design the testing process and the evaluation process for that robot.
Oh, sounds very interesting. Well, should we go take a look at what they're doing?
Come on in. So here we have Ryan and Tate that are working on their robot for retrieving and storing disc golf frisbees. So maybe you guys could tell us a little bit about how your robot works.
Yeah, so currently the claw is disattached, but it will rotate up, and these are meant to squeeze the disc to hold it in place. Once it gets to its max height, it will drop it, which will then roll down farther because it has gravity as well. And then it will go backwards. Oh, battery's dead. Great timing. But this will rotate back, and this will too. And they'll store the disc slightly farther back, so the next disc that's pulled up can then be dropped down and stored again. Slightly more complicated than necessary. We probably could have just made it so they were stored flat, but I mean, it's more fun this way.
So this is Anna and Amanda, and they are two international students that are with us for this semester. And maybe you guys could just tell us briefly what your robot is designed to do.
So we built this scoop to take some objects. We have some little ping pong balls in mind. Our robot should catch them. Then we'll bring here, and you want to store these objects, like these balls and objects like this. We want to store them, and then we are building a door to release them.
So we set up with basically an elastic band across here just to hold the projectile in place and fire it. We just wanted a robot that could basically launch a small projectile. So you have to load it manually by dropping this bar in place, and then the gear system here can pull it back with the controller. And when it reaches a certain height, the lever that's holding it down is lifted up by this bar that we have here, and it just shoots. So with the component.
Well, thanks a lot, Trevor, and thanks to all the students, and I encourage everybody to check out our engineering program online.